My name's Philip Taylor. I'm with Hydro International. I'm Hydro International's Stormwater Solutions Specialist. I've been with the company about 10 years now, and I've worked in the stormwater department for that time in various locations, working with different regulators, engineers throughout the US. So I've developed quite an understanding of the stormwater industry. So this presentation, it's going to be about 30 to 40 minutes. There'll be PDHs available at the end of it. We'll send those out automatically, and following that will be a short 5-question survey will follow. I appreciate if you would fill out that survey. It doesn't take much more than probably 30 seconds to do. We're going to look at a little bit of Hydro International. We're going to look at a little bit of the Baffle box design, do an overview of that. I'm going to look at the Hydro DryScreen development, testing, sizing and scaling. I'm going to go back and we'll get back to that sizing spreadsheet where I just realized that I had my microphone muted. Look at maintenance and then a summary. So Hydro International, we're a small company that works throughout the world, various locations, providing stormwater and wastewater solutions. Headquartered in the UK, listed on the London Stock Exchange. North American operations are based out of Hillsborough on the East Coast, on the West Coast, and Portland on the East Coast, and the stormwater is all handled out of the East Coast office. We also have a stormwater engineer based on the West Coast to provide time zone coverage. We cover 3 main industrial sectors. We do wastewater treatment, wet weather flow, and stormwater treatment. Now the stormwater treatment is where I concentrate my efforts on, where we have the downstream defender, the first defense, we have the hydro DryScreen and the upflow filter. We also supply vortex flow control valves as well. So screening technology, we have a range of technologies across our businesses. They all are similar. The development of the hydro DryScreen really is a new development for us, but screening is not a new development. So if we want to look at baffle boxes in general, we did this. We looked at the industry and looked at what was available in baffle boxes, and generally what we find is that you get a type 1 baffle box. This is a simple baffle box. It's usually just either a simple chamber or vault, and it might have 1 or 2, maybe 3 chambers in it, separated by vertical baffles within the wall. Dr. Pandit, or Professor Pandit, sorry, down at the University of Florida, did some testing of different designs of baffle boxes, and he found that if you have 2 baffles and 3 chambers about the same size, that's about the optimum design. You don't really get any benefit from changing that design. So adding an extra baffle doesn't help, taking a baffle away doesn't help. So 3 baffles is about where you want to be. And then adding a screen on top or a basket on top, that helps remove debris and trash and improves it to what we call a type 2 screen baffle box. Some refer to as a nutrient baffle box. So where do these fit in the toolbox of engineering tools for treating stormwater and cleaning up stormwater? If we're talking sediment removal, you have filters. They're the optimum product. They'll clean the smallest amount of sediment out, although filters themselves tend to be load sensitive. They can be overwhelmed by high concentrations. Separators sit in the middle somewhere. They remove around about 50 microns for that coarse to fine sand, maybe even some coarse silts. But they don't do so well for maybe neutrally buoyant material. And then baffle boxes, not so good on sediments, 500 microns, maybe the coarse sands up and larger, but they do pretty well with things like neutrally buoyant material and screening out trash and litter. But if we look at phosphorus, now particulate phosphorus, which is the solid bits that contain phosphorus, filters again very good, although again load sensitive. Baffle boxes now do a better job because baffle boxes tend to remove a lot of trash and organic debris. So if you're looking at leaf load with associated phosphorus loads, they actually can do quite a good job. And then with separators now, maybe less likely because they tend to wash through a lot of that material. So here's a photo I took. This was taken down in Kentucky. I took this photo while riding along the, I think it was the Legacy Trail, yeah, along Cane Creek or Cane Run down in Kentucky near Lexington. And this really struck me as why we want a baffle box with a screen in it. Because a lot of that material there, you know, when I looked at Google Maps and measured the distance just out of interest, you know, my wife looks at me strangely when I'm riding along and I stop and take photos of trash and creeks and stuff. The nearest outfall to this runs through farmland, through horse parks. The nearest outfall was the Interstate 75, which was a mile away, and the nearest residential area was another mile further upstream. So this trash has traveled at least 2 miles, probably from the nearest residential area, a mile from the highway. And if this is typical of what's in the stream, there's a tremendous trash load going into the stream. So for treatment and protection of lakes, rivers, beaches, LID practices, this is where the baffle box really shines and what it should be used for and why we should be using them. This is clearly getting through whatever protection is available upstream. The other side to look at the thing is organic load. Even though, you know, the tremendous amount of load may be picked up through street sweeping, what I find if I look down my street, and I live in Wisconsin in the fall, and everyone sort of starts raking things into the street around October, November. For some reason, that time of year, it also rains and blows a lot. So before the city can pick up anything, a lot of material is actually washed into the storm sewers, and that's where a screening system, end-of-pipe screening system that can take a large load or a large flow is a really useful backup to maybe a street sweeping program. So in developing this product, it was important that we sort of look at what's available in the industry. And when we started looking at the industry, we didn't find a lot of really good stuff, you might say. We saw some development of baffle boxes, but when we looked at them, we really thought, well, you know, some of them don't really optimize their screening area. They don't really control the flow that well. There's very little test data available, and the sizing tables aren't making a lot of sense to us. So we set some design parameters and started looking at how to improve things. We wanted to control the flow path. We want to maximize the screening capacity. We want to treat the screenings dry. And we need to provide tools and sizing information that makes sense to an engineer. When we first started modeling these, and this is pond design 101, really. You don't want your inlet lined up with your outlet and a plug flow going straight through from the inlet to the outlet. It doesn't really optimize your design of a baffle box, and also it puts a lot of energy into the basket where the material that you're trying to capture is going to be sitting. And so you just don't want to start hammering it with high flows. So our solution was to try and split the flow and direct the flow to the sides so that we didn't get direct flow from inlet to outlet, and that's how we developed basically our baffle box. To maximize the screening, we made sure the screens went from wall to wall, from front to back, and put a flow splitter in there, and that's the sort of the area that we worked on to develop an improved baffle box system. And then we built this model. This is a 3x6 model, and you know, once you do your modeling and stuff, you want to do some testing and see if maybe your test ones are going to reflect a little bit of the modeling. And when you see that you do get this reflection that the testing and the modeling start to line up, you get a better feel that what you're doing is along the right track. So once you've got your model built, you start looking at testing as well, because people want test data. We looked at what was available in lab testing. And most testing on baffle boxes is using a fairly coarse particle size gradation. Very little testing is done in the finer range below about 100 micron. And that makes sense because these are not high TSS removal devices. These are lower quality TSS removal. They're more screening devices. But having said that, they're sized basically on TSS. So we need that information. Load rates, we found around between 5 gallons per minute per square foot up to about 150 gallons per minute per square foot are sort of load rates. And removal efficiencies ranged from the mid sort of 50s up to 90 to 100%, depending on what size you use and how much load rate you put it on. So there was some data there. Now, the field data that we could find really showed there was a lot of variability in field testing. And field testing is so hard to control that you expect variability. So we really couldn't get much indication about field test performance. So basically we just ignored that. So in testing these units, we changed the, well, we didn't change it, we looked at the particle size gradation that was being used by Dr. Panda. We looked at some of the particle size gradations used by some of the other vendors, and we settled on this Pandit blend. We called it the Hydro Sandy Clay, which is really Dr. Pandit Sandy Clay. It was the finer sort of blend he mixed up, and we did similar testing, so we had some idea of where we're heading. And also what we did, we subsetted that particle size, so we knew what subset grades we had. So from 1,000 microns down to 425 and 1,000 down to 300, we knew how much we were putting in, so we could measure how much of each of these subsets we were removing in our testing. That means that if an engineer is working, say, on a site that's pretty coarse material, they could decide that you know, it's mainly coarse sands, maybe some fine gravels or something like that coming off that site, then they could design with something, say, down to 425 or down to 300 micron. But if you're working on another site, maybe more of an industrial site where there's more heavy equipment running around, you might be getting material ground up to a finer particle size, then you can select the particle size down to, say, 106 microns as the smallest particle size targeted. And that's generally what we find in these devices. So we have that range of particle sizes to design with. And the other side of it is that, as mentioned it before, baffle boxes are kind of miniature settling ponds. So their design is based on a similar principle. It's a load rate, gallons per minute per square foot load rate. So if you have the same load rate between two boxes, the difference is the flow rate. So, you know, in my top example of 4x8, 32 square feet, if that's loaded at 140 gallons per minute per square foot, you would say have 10 CFS of treatment. And if you had a smaller box of 4x6 loaded at the same load rate, you would have 7.5 CFS of treatment, but both would be removing the same amount of material, or 80% TSS, say, and just for an example. This is where things got a little startling when we looked at some of the vendors out there putting out test data. We found the load rates between different devices for the same removal and the same particle size weren't consistent. So they varied significantly from very low to very high. So this is the same box removing the same particle size for the same removal efficiency, but just different size boxes. They should all have consistent load rates. We settled on a consistent load rate scaling. That's the standard in the industry, but we're finding that the load rates scaling between smaller units and larger units on a lot of these vendors are variable, and considerably variable, which is a bit of a red flag in terms of that, and we don't know why exactly, but it does show maybe some inexperience or lack of understanding on how these things work. So it's just a bit of a red flag we saw. So we put all that information, threw it into a sizing spreadsheet. I'm just going to go through that sizing spreadsheet now for you. I'm just going to switch what I'm presenting here, just 1 second. Now you can download this sizing tool from our website. If you go to hydro-int.com, go to the US website, it should get you there by default. If not, just check up here that you've got the little US flag up there. Go to the products, Stormwater, Hydro DryScreen, click on that, you'll end up on this page. On the right hand side you'll get the download the sizing tool, or sizing calculator. So this tool was right there, easy to find. The tool's a simple spreadsheet, so it doesn't require macros or anything to run. You don't have to beg permission from your IT administrator to load up any software. you can just download it and start using it. Top box is fairly self-explanatory, just all the project details you want to put in there and a selection of either metric or US units. There's some little boxes up here you can check for an update of the spreadsheet. I update it occasionally and put a new version number up, so just click that box and see if you've got the current version number. You can submit a design for review. That just goes through a submission process, gathers a little information, and you can attach the spreadsheet file itself. And you can also just click this box here, which will send me an email, and you can ask me any questions you like on it. So to do a design, you go down to the treatment parameters here. You simply change the treatment parameter. It'll update automatically and gives you a summary of the standard sizes as well as a custom size vault. You can select the particle size you want to use. So these are down to, so they're different particle sizes, trash removal. So you just select that and you put in your treatment flow rate. As I say, everything updates automatically as you do it. You can size different screens. I know in California, the standard screen we use is a 19mm or 3/4 inch screen. In California they have some regulations in areas where they need a 5mm or 0.19 inch screen to screen out cigarette butts. So you have the standard range of sizes here. The red box shows that you haven't got 80% removal for these standard sizes. You might have to just change some variable if that's what you're targeting. In the custom vault design, what this does, it allows you to optimize the vault to remove exactly what you're asking to remove, and it's no bigger and no smaller than it needs to be. In some cases when you have a list of standard products, you just get over the size of the smaller one, but you're almost, the bigger one is too big. So you're stuck in this area where maybe you don't want to buy the $200,000 one, you only need the $50,000 one, but your switch over is that switch over point. So you end up spending more money than you need for the treatment you really need. So this custom vault design allows you to get around that. And you can just input the short side of the vault. It calculates the long side. If it shows red, it means you're a little bit oversized. You've got to just change that a little bit. So it gives you a custom vault size that is sized exactly to the size you need. Now to select the vault, you go down to the layout area here, and the custom vault is at the bottom of that all the time, or you can select the standard vault. You can then just put in pipe sizes you need. If you put in a pipe that doesn't fit, you'll get a warning. It'll still carry on, but you'll get a message saying, hey, you're a little bit oversized there, you might want to revisit the pipe sizes. And you can put the levels in, and the same thing, it'll give you the minimum cover required, so you can develop a design for your site. And then these are translated into a simple drawing, and that drawing can then be just printed out. You can print this whole thing out, submit it with your design, or put this on your plans. And the other tabs give you a specification. There's a Word document there you can download and customize. There's a brochure there as well, and some links to some other stuff there, and a bit of a user manual on this tool. So that's a simple design tool. It allows you to get a very quick design done. You don't spend a lot of time on it, and you're good to go. So that's the tool. Maintenance side of things. These are standard Vector truck maintenance. You don't need any special tools, but you may need confined access. There are screens in there that have to be lifted and moved out of the way once you've vacuumed out all the trash, and so there probably is likely a confined access requirement. That's fairly common for most of these stormwater screens. You'll have multiple lids you can lift, screens that have to be moved out of the way, and then you vac them out. And so we have a maintenance service division which can provide quotes for all this. Now, some of you are probably wondering, what do these things cost? We're finding that the cost is quite variable throughout the US, because we like to use local precasters to do the vaults. We find that the significant variability is the cost of the precast. So we have to go to local precasters and get a quote basically for every volt, but we're finding smaller volts. You might find 4x8, something like that, could vary from 20 to 50,000 depending on the precast, and the larger volts, maybe a 12x20, could vary from 55 to 150,000. It's that variable depending on local concrete pricing. So we price each one individually, and it doesn't take us too long to do that. So if you're looking at a job and you need a quote or you need some idea of the cost, the best thing to do is email us. We'll get the local rep involved and they'll get a cost put together for you. So that's the hydro dry screen in a nutshell. I apologize that I had to go through that twice and I forgot to turn my microphone on the first time. But I think we're not doing too badly, about 45 minutes. So thing to remember about the hydro dry screen, we have spent a fair bit of time studying these and understanding the industry and making sure that we have some consistent design. We've done a lot of controlled testing and we've put together a nice design tool for you. We've maximized the basket and kept that basket dry between events. Large screen area. Now just to let you know, we blinded off these screens 80%. So we put solid covers over 80% of the screens, redid the testing and found hydraulically there was almost no difference in the flow. So as these blind off, you're getting very little drop off in flow. And if you do get a significant blinding or covering up of the slots, the back screen is also a bypass wear, so water can wear over that if it needs to. We keep it a large open area in the front so that we're not blocking the inlet pipe, and you can have customizable designs. If you have any questions, please email me. My email address is there. It's ptaylor@hydro-int.com. I'm here for the rest of the week. Feel free to email me. I can answer your questions generally straight away. And I'd like to thank you for attending, and hope you have a good afternoon, and to follow will be a short survey. Thanks very much.